Welcome to video number 8 of our Blind 75 series. We have up till at this point wrapped up all the problems related to arrays and hashing. And now we're going to be focusing on problems relating to pointers. So in this problem, mainly is palindrome. We need to check given a string whether that string is a palindrome. Under this problem, palindrome is defined as a string that reads the same forward and backward. It is also and in this case, we need to remember that this assignment is case insensitive and ignores all alphanumeric, non-alphanumeric vectors. So first, let's go and explain what this problem is mainly, right? So once we have our pen here, so we need to make sure that it is case insensitive. That's the important point, and we need to make sure it ignores all alphanumeric characters. Those are the two. That out of the way, there are two ways we can solve this problem. And one way is probably the easier and a quicker way, but unfortunately, in some cases, that might not be permitted during this problem in your coding interview. So we're going to go over both methods. So the input here is basically, was it a car or a cat I saw? That's the input. You want to check if it is a palindrome. So what is a palindrome? Palindrome is that if we remove all the alphanumeric characters, uh, this particular sentence of input that I just highlighted here, let me just put it in a box so you can identify this clearly. So this sentence here, if we remove all alphanumeric characters and all spaces and bring it here, it looks something like this, right? We need to understand if if a word if you remove all alphanumeric characters and remove all make it case insensitive, it looks something like this. How can we check whether a character is whether this input string is a palindrome or not? Number one, the easiest thing is, right? So if we reverse the word character order, if we bring the words that are at the start at the end uh, and words at the end at the start, would the sentence remain the same if we highlight the words here? Was it a car? Right? Those are the first words. Similarly, if we reverse the words, we're going to read it from backward. So WAS, if we read this as backward, it's something like this. Was it a car? So it pretty much is a palindrome because the words reversing them gives us the same sentence. But there's another way you can look at it. So if you have an odd number or even number, it would be even easier. But if it's an odd, as it is right now, if we can draw a line between the number right in the middle, right, and ignore that number now. Now, if we superimpose these two images, these are mirror images of each other, right? That's another quick way to identify if it is a palindrome or not. So, with that out of the way, how do we solve this problem, right? That's the question. So, uh, generally speaking, there will be three things we need to do in this problem. We need to first filter out all alphanumeric characters. Uh, Number two, we need to ignore all cases and make it case insensitive. And number three, we need to check if filtered string reads the same forward and backwards. So those are the three things that we need to check. A very, very easy method, as I mentioned earlier, would be to just use chain together simple methods that are available to us in Python and solve this problem. So let's do that quickly and then come back to the main problem at hand. So let's move to the screen to the other screen and need to write the code that converts this. So we write a new variable which chains together certain methods and uses comprehension to basically process the input that we're getting here, converting the string to lowercase and removing all alphanumeric characters. So let me set that up. We're going to use the dot join function to join it all the words and not keep any space between those words. Then within the dot join function, we're going to set up a comprehension to further process this word. star.lower method to pretty much lower all the convert all the words in the string into lowercase. Here we use the all num function at the end. So we're going to first convert it to lowercase. We're going to convert any character to lowercase if and then we set up a filter for character in S, which is the string, if that character is an alphanumeric character. So we just solved the major problem of this assignment, do making it lowercase and you checking if it's alphanumeric using this simple method in Python. And that is the probably the issue with this problem here. It comes too simple and it doesn't actually test your capabilities as one would want in a coding interview. Some coding interviews might accept this, but some might not accept this method at all and might explicitly mention that you can't use these functions to solve this problem. But we're still gonna quickly complete this problem and then basically uh, you know uh, see if we can solve it in another way, basically. So next we need to check, we need to return uh, true or false, right? But we need to check if filtered str is actually a palindrome or not. We've made all things, we've made, uh, we've made, processed everything as needed. But now we need to check if they're mirror image or not. So what we'll do, we'll compare filtered string with uh, 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 a mirror in reverse or reversed order filter string, and if it is equal to each other, then uh, then it is basically a reverse. So let's run the string, and the expected should be that it basically solves both cases. And in this case, it does solve both cases properly, which means this is the correct solution. But again, in harder coding interviews, this might not be permitted. On to the second solution. Generally speaking, uh, I was before actually that the time complexity of this meets the standard of O of n, but again, like it's not the time. This approach, even though it solves the problem efficiently in time or with time complexity of O of n, but the issue here is not time complexity. The issue here is that we use the method to solve a problem very easily, and that doesn't test certain capabilities that might need to be tested in a coding interview. So with that out of the way, next we need to check if a letter is if a letter is mirror image of it of each other or not, basically. So next we need to use the pointers to do that, and that gives us the time complexity that we're seeking, as well as it makes sure that we are able to solve this problem in a way that they want to test. And this is the pointer problem mainly, so they need to see us using pointers uh, to see if that is possible or not. So how do we do that? So let's go back to our whiteboard here and remove these lines. So imagine a pointer is basically a focus by the computer to focus on one aspect, right? So we are going to have two pointers. Logically speaking, there are going to be two pointers at the start, at the end, right? Once we have converted the value into from by removing non-alphanumeric characters and removing any making them lowercase, we need to initiate two pointers, right? And at every step, those two pointers would have a word or a character that they have say they're pointing towards. Now we need to make sure we compare those pointers. So we're going to compare this value of this value pointer, bring it over here, and this value pointer here, and make sure that they are equal to each other. If they're equal to each other, well and good, we move to the next. But if they're the moment they're not equal to each other, this is no longer a palindrome. So as these are equal to each other, they're palindromes. So we shift character, which is A. I'm sure you're following me by right now. As they're mirror images, as we move in reverse order, the pointers on left and right, the words should be the same, right? And this is going to they're going to do these comparisons over and over again, and the moment the one comparison is not equal, that's the moment when we can declare it's not a palindrome. But if all of these are equal, then it is a palindrome. So we're going to continue this until we reach the R here and the R here. And as O is the dividing point in this odd string, that is the point where we don't need to test. But this at this point, if this R is equal, these R's are equal to each other, which they are, then we can declare that is this word is a palindrome, which means let me write this down. Which means if this is a palindrome, is also going to this means that we need to return the value true in Python. And once true is returned, that means we have successfully solved this problem. So that is the logic behind this problem. So now that we understand this logic, let's go back to our program and let's now code all of this out, right? So first, we're going to bring our first pseudocode in. Let me pull that up. We need to convert the strings into lowercase. So that is the first pseudocode that we need to work. So dot lower function is not prohibited because that is not the test that we need to run. So we're going to pretty much create a new variable and lower the string. So we're going to say s equals s dot lower and use this method, right? That's out of the way. Then we need to initialize 2 pointers, and this is the technical part of this problem. We need to work with pointers here. We need to have 2 pointers and basically set them up in a way to to check for characters. Basically, the 2 pointers approach should compare the characters from start to end. One should move inward, both should move inward, and then ignore alphanumeric characters. So there's another aspect to it actually, right? I think we while we were going over this explanation, we missed one aspect to it, right? Let me uh, actually could do that again so that we can get a little better uh, clarity over this particular problem. So let me bring this over to the whiteboard, go to a cleaner slate on the whiteboard, get this printed out here, just increase the size of this here. So potentially, if we had pointers, let me open my pen again. So if we had pointers pointing at W right here, and this might be the this might be the logic that we might code out practically. We see W is an alphanumeric character, right? We've already lowercase. Imagine all of this was lowercase, right? Just keep in mind the spaces are still there and the exclamation, any punctuation is still there as well. So we have W here, which is alphanumeric, so it's fine. W is going to remain as is. But we have a question mark here, which is not an alphanumeric character. We need, even if it's not an alphanumeric character, which it isn't, what we need to do is simply shift the pointer inwards again, right? So instead of doing the test of comparing the characters with each other, if there's a non-alpha numeric character, we shift them inward, the pointers inwards immediately. So we only compare alphanumeric characters. We haven't converted the values into alphanumeric because that might probably take a lot of time to code that particular aspect out. But we can easily check if a value is alphanumeric or not, and then if it was a non alpha numeric value, we can switchly move the pointer inwards without doing the comparison test, and until we reach the alphanumeric character and then do the comparison basically. Similar would be the case if we, for example, if this was here in the space area, right, and at the same time this was on S here, right? So what would happen is that again as this is not an alphanumeric character, this would be shifted to I here, and then do the comparison and so on and so forth, right? So that's how this problem would address this problem. So a problem would address the alphanumeric issue. Um, this So now that that's out of the way, we need to code the two pointers along with the we basically need to set up the two pointers and position them properly. So we're going to write left comma right. We're going to initialize the values of those pointers as together. So 0 would be the value of left, and len 1 would be the value of the the right character. And you can make that sense in the sense that we need to reverse the order of the pointer. So we're basically positioning these values in the sense that they're going to be the pointer locations and where they start, the pointers start, their process from. At the same time, we need to basically set up a metric to go over this process over and over again to make sure that it keeps on working unless it reaches a point where there's a certain restriction where it stops basically. So in this case, the left is the variable that's moving inwards and increasing in value, and right is the variable that's decreasing in value. The moment left is not larger than right, it means that they have crossed over each other. Let me explain that on the whiteboard again. So potentially, R is the O is the difference between these 2 points. That's the mirror point right here. So if this mirror point, in this mirror point, when the value of R of a left pointer, which is this should be this side, this should be the left pointer in this area. The moment the value of the left pointer is less than the value of the right pointer, it means they have crossed over, right? Or they have reached the middle point. And as soon as they reach the middle point or they cross over the right pointer going over here and the left pointer going over here, that is the point we need to stop the process, because at that point we have covered the two mirror images that we need to check for the palindrome. And after we have checked that, we need to exit out of the code and confirm whether it's a palindrome or not, basically. So with that that notion in our head, we go back to our code. We write we create a while loop while left is less than right, tables that we find, and we have the while loop sorted out. Then we need to basically, after that, we need to work on the left pointer, basically. So the left pointer needs to move to the next alphanumeric character here, basically, start at the start. So we need to do that. So to do that, we need to write while left is less than right. That is like this is incomplete and not, because we need to add an additional condition, because that condition is being tested in the superseding while loop, not an alphanumeric character. So we need to set those uh, definitions here, which is A is basically is either not an A character from A to Z. As we have lowered it, we're not going to check for uppercase A to Z. So we're going to check if A less than S left, which is the pointer left is the and that is less than equal to the character Z, or another bracket here. And now we need to test for numbers. So we need to test for 0 to 9 as well. And both of those are that in a similar manner. So less than equal to S left 9 string format. Have that sorted out, and that while loop is done. And then we basically deduct 1 from add 1 to the right, because we're moving inwards here. So here oh sorry so here what we're testing for is that as long as as long as the value remains is not a to z or 0 to 9, we need to run this while loop and immediately shift right one step inwards. And that is what we were talking about earlier, because we're not going to convert it into alphanumeric characters in the processing as we did in the earlier example, because that's going to take a lot of time and it's probably going to take a lot of resources that we don't have in this problem. We need to be as efficient as possible in solving this problem. So to do that, we need to make sure that we're able to shift it to the right if it is not an alphanumeric character instead of converting it to it. As we discussed, probably the easiest example at the start that I gave you, if I open that again, was this one here, right? This particular way of solving is probably the easiest for you to visualize. That's why we went over it, right? But this is probably not the right way to do it if you can't use the isnum to completely isolate non-alphanumeric characters immediately, right? So if you can't do that, then you have to deal with this here, right? And if you're dealing with this here, you need to make sure that you are able to isolate or recognize these non-alphanumeric spaces and skip them and ignore them. And that's what we're doing. As moment the pointer points out to non-alphanumeric space on the right side, it immediately shifts using this while loop to the right and moves to the next character immediately and points out towards that character next, right? So that is what this particular code that we went over and wrote out is doing. Now, with that out of the way, we probably need to do the same thing for the left side. But let me bring in, you know, bring in write down the code to do that. So as long as left is, we need as long as on the other side left is again less than right, because again that is our control mechanism, right? It's not going to change right, because the moment it changes, it's not going to at that moment our logic must stop. So moment that's done, and and it's again not alphanumeric. So let me just simply copy all of this. It doesn't make sense to write down again. Copy all of this here, bring it down here. So now we have that sorted out as well. But oh yeah, we need to remember that we need to change this from S left to S right. That's what S right is not an alpha numeric character, then we need to, oh, yeah, we need to change this to left. Again, like these are things that you might make mistakes when you're coding things out. And here you write down right from right side, which is to the left, which means we move backwards here by one, right? So that is how we pretty much work with alphanumeric characters in this case, right? And then I think the next thing we need to do in this while loop is to check if the characters at left and right are not equal, right? The moment that case is true, we're going to return false and exit the loop, basically, because the moment the characters are not equal, it's not a palindrome, right? So if the moment it's not a palindrome, it means that we need to exit the loop because testing for. And the moment even a single character is not equal to each other in the specified places that we discussed in this problem at the start, that means that this particular string is not a palindrome, and we can exit this problem. Similarly, if that is not the case, we need to, at the end of the loop, continue, because here you'll notice the fact that we're doing two things here. We're not testing for positives, we're testing for negatives. Because the moment a negative comes in, we can exit the loop and we have a conclusive opinion. But the moment no negative pops in, at that moment we know it's a palindrome and we can return true after the end of this while loop. So again, we move if everything works as expected. It's an alphanumeric example. We tested if it's not left or right are not equal, and if that is not the case, we just basically left this first. So we add again, go back. We add one to left and remove uh, uh, run from right. And once that is done, we can exit the while loop and return true. So let's go back return true from this particular logic, basically. I think you can understand how this logic is flowing in this example and how we're testing all of these aspects using the pointer. So when we run this code now, it should potentially be true for both cases. Now, this is true, and which means that we have successfully completed this assignment. Now, before we wrap up, there's one thing you need to remember. Like the first example is a good solution and a quick solution, which might show that you are very quick on the uptake of the problem and are able to solve this. But at the same time, in most cases, you'll get more points or more, you'll give a better impression if you use this logic where you're not trying to use alnum, even if it's not. But do mention the fact that you could have two potential solutions to this problem, but as presumably we can't use built-in Python methods to solve this problem, I'm not going to use the alnum to check for that and solve this problem, basically. So this is pretty much the solution for the Is Palindrome problem in Blind 75.8. And with that, we're going to wrap this video up, and we'll see you in the next video. Thank you.